Cool. Ready when you are.
Hello and welcome to another day at streaming school. Today we didn't have any motivation in the morning, unfortunately. Jackson had to do a couple of things out, but I am joined for our first session by Sam. Sam, how are you?
Morning, Nish. I'm really good, thank you, and hopefully I can give a bit of motivation for those on this Wednesday morning. So I'll do my best to motivate everyone at home.
Yeah, exactly. Enjoying the weather, trying to enjoy it.
Yeah, I will definitely be out at some point today, Nish, enjoying the sunshine. What about you? What have you been up to?
Yeah, just I'm sitting in a room that has lots of sunshine, so I'm trying to sit in the same spot so I can just soak it all in while I'm working. But it's okay. It's all right.
Well, as soon as this is over, it's time to get out there and enjoy the sun. But yeah, I'll crack on with my maths. And
yeah, cool. It is all yours.
Brilliant, thanks, Nish. Well, so today we're going to look at recapping quickly the stuff that we did on Friday. So we spoke about circles, circle theorems, and today, through the magic of technology, or not, we're going to use the whiteboard for once. So hopefully that will give you another way of interacting with the lesson itself. So yeah, Nish, if you can share my screen, please.
All right, cool.
So if we start off by recapping, so we looked at area and circumference of circles. We spoke about the diameter, which of course is the line that goes all the way across a circle through its centre point. And then we've got the radius, which goes halfway from the edge of the circle through to the centre point. Of course, the formula for area of a circle we said was 3.14, which is better known as pi. And then that's times by the radius squared. For circumference, it's pi times diameter. Then we looked at the properties of circles, and you've got some pictures here. The tangent line is a line that goes and just touches the outside of a circle, and a chord is the line that goes straight across from one part of the circle to the other without going through its centre point. Then we looked at some circle theorems, and we spoke about quadrilaterals within circles and how they must add up to, the opposite angles must add up to 180. So you can see here you've got 88 degrees, and its opposite angle is 92 degrees, which will give you 180, and then the same here. So opposite angles in a quadrilateral within circles would be 180. And then we briefly spoke about substitution, but we're going to recap substitution and go into a little bit more detail today in terms of what we spoke about in substitution. So today we're going to first start off with Venn diagrams, talk about the set notation in Venn diagrams and what the set notation looks like in terms of shaded areas and shaded regions. Then we're going to look at some exam questions and finish on substitution. So without further ado, we're going to look at Venn diagrams. So of course, here you've got two circles, and we'll go onto the whiteboard and do a demonstration in a minute. So you've got two examples of the Venn diagrams. Now, in terms of the Venn diagrams, you need to understand the different terminology. So you have the universal set, which is all the information within the rectangle. Okay, so you might have numbers in the circles, you might have numbers outside the circles, and that's called the universal set. That includes absolutely everything. Then you've got the intersection, which is the section in the middle where the two circles overlap. That's what we call the intersection. And then you've got the unions as well. So that's where you think of, you might have some numbers in the circle on the left, or you might have circles on the right. Okay, so that's information in both circles. And finally, if you had, in fact, we'll go into more detail in terms of this shortly, but if you had information in the odd numbers with an apostrophe, then that would actually take out information from that circle. We'll go into more detail shortly, but if we can share my whiteboard, if you just bear with me a second here, you've got my whiteboard now, so we're going to look at that examples. We're going to look at that example where we had the numbers 1 to 10, and you've got the Venn diagrams that look like this. So here's the intersection of the Venn diagrams. You've got a set of information on the left-hand side, so we'll go through our odd numbers between 1 and 10, and start off nice and easy with number 1. And then we're looking at, of course, we've got the universal section as well for any numbers that aren't odd or multiples of 3. So, for example, the number 2 is neither odd nor a multiple of 3. So we can just put a 2 outside in the universal section, in the universal area. Then we look at the number 3. Well, of course, it is an odd number, but it also is a multiple of 3. So therefore, it overlaps and goes into the intersection. The number 4, of course, is neither odd nor a multiple of 3. 5 is odd, but it's not a multiple of 3. 6 isn't odd, but it is a multiple of 3, so it goes into this section on its own. 7, we've got odd. 8, of course, is neither odd nor multiple of 3. 9 is both, so again, that's going to go into the intersection here. And then finally, we've got 10, which would go there. So all our even numbers, with the exception of 6, are going to go into the universal section. 3 and 9, because they both overlap as odd and multiples of 3, they're going to go into the intersection. And then 1, 5, 7, and 6, they're in their unions on their own. Okay, so if we come back to the screen now, you've got another example here. So you've got students with brown hair, there's 3 of them, so they would be on their own here in the intersection. And you've got glasses, so students that wear glasses, there's 2 students on their own that just wear glasses. Now, of course, that tells me that they don't have brown hair. And the 3 students that do have brown hair, that tells me that they don't have glasses. However, the 1 student on their own, that tells me that they have both brown hair and glasses, whereas these 4 students have neither brown hair or glasses, or wear glasses. So that's an example of 2 sets of Venn diagrams. Now, of course, in your GCSEs, you might have 3, possibly 4, but predominantly 3 would be the most you'd have to work with. Okay, but it's the same principles. So in terms of the set notation and what these mean, here you see the shaded area in the middle of both Venn diagrams, and that's just to explain that the information is A and B. So if we put A and B together, that is the information that you get. So the intersection, of course, is where 2 sets overlap, and if you see the symbol A and B, which is, sorry if I go back to that, it's a funny looking N, if you will, and that describes A and B. The second is the union. So the upside down shape here, that describes the union of both sets of A or B. So it could be anything across both unions there, as well as the intersection. And then finally, and this is what I spoke about briefly earlier, is the letter with the apostrophe would mean it's nothing to do with that section. So not only the intersection, not only the intersection, but also that full circle there has nothing to do with that part of information. That will include the universal set, and the universal set can be sometimes shown as a U, universal, or also, if you see at the bottom here, you've got an E looking shape, which describes the universal set of data. So here you've got 6 shaded regions for Venn diagrams. You've got set A on the left and set B on the right. Of course, you've got, as I just said, you sometimes have the letter E and you have the letter U, U for universal. And what we really need to do, and you've got the answers at the top of the rectangle anyway, but you can see there that A and B is demonstrated by shading the middle intersection. A union B is demonstrated by shading all of the Venn diagram itself. Anything here but not A, so everything is shaded, including the universal area, because we don't want to shade anything with A because of the apostrophe, which tells us that. Down here we've got A and not B. So A and, remember this is and B, of course because it's got apostrophe, then it means nothing to do with B, so we shade A. Again, same process here, but this time it's not A, we're shading everything with B, excluding the intersection because we don't want to have anything to do with A. And then finally, again, if you see the union sign, we're going to colour in and shade in the outside with the exception of anything to do with B. So I hope that helps demonstrate and make it clear for you in terms of how to shade your regions when doing set notation and Venn diagrams. Here's some questions for you based on a teacher and the 24 pupils she has in her class. You can see at the top of the screen you've got S for sisters, B for brothers, and the questions basically say, describe the blue region in words. So you'd say something along the lines of, there are 7 students in the class that have a sister, and there's 5 students that have both sisters and brothers. We know that because we've got sisters here, where the 7 represents, and 5 in the middle is where they both overlap, so where they have both a brother and a sister. Describe the region, not S union, not B, in words, and that just basically means that's the 4 that we're looking at. So down here, who doesn't have a sister or brother? And of course, there's 4 people that don't have either a sister or brother. How many students are how many students are not in S? So this means not that don't have a sister. And of course, that's the numbers in blue, which is the sister. So altogether, there's 12 people that don't have a sister, 8 that have a brother, and 4 that don't have either. Work out P, S, and B. So in other words, P for probability. So what is the probability? And we could write this answer as a fraction. What is the probability of having a sister and brother? It's sister and brother. Therefore, there's 5 people that could have both, that do have both. If it was a fraction, we'd write it as 5 over 24. So altogether, 7, 12, 20, 24. If it was a fraction, you'd write 5 over 24. And then finally, for question 5, what is the probability of not having a sister and brother? You'd have a brother, but not having anything to do with sisters. So if you look in the brother box, you've got 8, and again, that's like 24. So 8 over 24, which you could break down as to 1 over 3. If you simplify your answer, 1 over 3, 1/3. Okay, so we're going to just spend a couple of minutes now on the whiteboard again. Here's a past GCSE question. If you're taking all the information, we're looking at, in fact, you can see the symbol up here that we spoke about earlier. Sometimes it's written as a U for universal. Sometimes it's the funny looking E that also demonstrates the universal set. So we've got 2 Venn diagrams. The information is that there's 150 cars parked in the car park. And there's R for red and J for cars manufactured in Japan. So what I'm going to do is share with you my screen, and we want to see if we can work out exactly the value of X and also the value of each circle. So if I share with you my screen again, we've got 150 cars all together. If I was just to break that circle up, we've got that information and that information, and of course the whole rectangle gives us that. So first of all, if we know there's 150 cars all together, what is the value of X? That will allow us then to work out how many red cars and then how many are made in Japan. So if we put the X's together, you know you've got 3X. I'm going to do this up here so you can see it probably a little bit clearer. You've got 3 X's all together, and that was plus 5, isn't it? You've got 3X, and then plus 5 minus 7, which gives us minus 2. The 3X minus 2, okay, we've simplified and put all the algebraic notation together. So there's our equation. Now we're going to look at making it into an expression. So we need to find out what it equals. At the moment it equals 150, but if we subtract 68 and 21 from 150, the 21 add 68 gives us 89. 150 take away 89 gives us 61. Okay, and what I've done is to work out how many of the cars are red, we've substituted them together, making an equation, and then turn it into to make it an expression. Sorry, and then turn it into an equation. I substitute these out, make it 61. So now, of course, what we do is the opposite, and this links in nicely into substitution. If there's -2 on this side, we want to get that to 0. So I'm going to add it on and do the opposite, an inverse operation. I'm going to add it on to the total here. So if we can get rid of -2 by adding 2, and then there we're just going to add 2 to the total. As you can see at the top of the whiteboard here, 3x equals 63. To find out what 1x equals, we just divide it by 3, that gives us 21. So x equals 21. Now we know we've got that piece of information, we can actually substitute 21 into this expression here. So 21 times 2 is 42. 42 add 5 is 47. There's 47 there. 21 subtract 7 is 14. And then you've got 21 and 68. If we were to add them all up, we would get 150. So those answers there, 47, 14, 21, 68. I go back to the original question. It says J, which was on the left-hand side, was the cars manufactured in Japan. R was the red cars, and a car is chosen at random. So work out the probability that it is a red car. So again, if we flip back from the board here, which just need to swap them over. So here, our red cars are just red at 21. Cars that are both red and manufactured in Japan, but is the crossover here, the intersection, so that's 14. So in answer to the question, how many cars are red? 21, 14, the answer would give us 35. Because it wants it as a probability, we're going to write that as a fraction, 35 over the total cars that we're working with, which is 150. Okay. Now I can see that in terms of simplifying that, 5 will go into both of them. Then you can have 7 over 30, which would be your answer written in simplest form. Okay, so there's an example of a GCSE style question that was given in the last 3 years of exam papers, and it links in nicely to our next topic, which is substitution. So we've got a few minutes left just to go through substitution. Now, an expression, which we wrote a few expressions there, that's where we don't know the equal sign. So, for example, our expression was 3x minus 2, because we had to add 2x plus 5 and x minus 7. So that's the expression where you don't know what it is equal to. And then the equation is where you've got the answer. So eventually we found out that there was 150 cars. Therefore, it was 3x minus 2 equals 150. And then we substituted stuff out. And you've got here the formula, which is an equation that has some textual meaning where the letters represent different variables. So again, it might be that you've got a equals 4. So what does 4a equal? And then just moving on to the bottom bit here, as an example, when you've got numbers and letters together, that always means multiply. So the example here was 3a, it's 3 times a. Okay, so in terms of substitution, just for the last couple of minutes, if you look at these examples, if a equals 3, b equals 4, and c equals minus 5, let's see if we can work out some of those questions. So for the first one, 5a plus 4, well, 5 lots of 3 is 15, plus 4 is 19. A times b, when a is 3 and b is 4, gives us 12. 3 times 4 is 12. And then it's add negative 5. And we know when it's add negative together, that gives us just a negative sign. So it would be 12, take away 5, which would give us 7. And then finally, you've got 4 lots of a times b. So 4 lots of a times b, which would give us 48. Then you're going to add a c squared. Okay? Of course, negative 5 squared would give us 25. and then you get 73. Okay, so again, a couple of GCSE style questions to finish off with. This was taken from the last 2 years of GCSE papers. Here on the left-hand side, again, it's nice and simple substitution. So A and B, and in fact, if I can flip back to my whiteboard, I'll go to this one on the screen. Sorry, on the board. So you've got A is 7 and B is equal to 2. So if we go A divided by B, and I'll just find that, and then subtracted by A, the power of B. Okay. Now we know that B is equal to 2. B is equal to 2, and A is equal to 7. So therefore, we've got 7 divided by B, and 7 divided by 2, which gives us 3.5. And then we're going to take away from 3.5, A to the power of B. Now, if A is 7, B is 2, 7 squared is 49. So what is 3.5? Take away 49, and you're going to get yourself a negative, and it's going to be negative 45.5. Okay. So that's how to work out question 1 on the left-hand side, and that will be a 3-mark question, so quite generous marks, I think, there, in terms of substitution. And then finally on the right-hand side, which we're going to go through tomorrow, in tomorrow's session. So that's the end of the lesson. Nish, if you can share my screen, please.
Yep, of course. There you go.
So we spent some time going through Venn diagrams today, which ranges from a grade 3 up to a grade 7, depending on severity or difficulty of the question. And then we looked at substitution, which we'll go into more detail tomorrow in our recap. But I hope you enjoyed today's tutorial, and I'll see you tomorrow for some more mathematics.
All right, thank you so much.
Cheers, Nish. Enjoy your day.
Thanks, you too.